Alrighty, but let's jump straight in. So like I say, we are currently busy with transformation geometry. And the last transformation that we spoke about was rotations. So and we're going to chat about all of our transformations that we have dealt with on Wednesday as part of our revision, but the most recent one that we spoke about are rotations. Now, just to recap what we've spoken about, a rotation is when we sort of turn a shape to change its orientation. It's sort of like attaching something on a wheel and turning it a certain number of degrees around in a specific direction in order to create a new image. Now, we spoke about 3 different rotations that we can deal with. Essentially, it's either going to be 90 degrees or 180 degrees. But when it comes to 90 degrees, we need to be mindful of the direction, and it will either be clockwise or anti-clockwise. Okay, so we're just going to recap some of the important things here, and then we're going to move on to our new transformation today, which is, what did I say? Enlargements and reductions. Okay, so if we go and have a look at our very first example of rotations, we've got triangle ABC, which is the green triangle here, and it's told me to rotate it 90 degrees clockwise about the origin. Now, remember, we need to know what the direction is. If we think about a clock face, clockwise, sure, my words stay, clockwise is in the direction that the hands would move on a clock. So if I'm going to move this shape clockwise, I'm having to move it down into this quadrant underneath. Okay, so remember, quadrants are just the 4 parts of my Cartesian plane that is split up according to the axes. And so we're moving from essentially what we call quadrant 1, 2, 3, 4. We're moving from quadrant 1 to quadrant 4. You don't really have to stress about the numbers of the quadrants at this point. Just know that we're moving into a new quadrant. Okay, now when we spoke about rotations, we spoke about the fact that there are different ways to do it, but one of the easier ways to do it is through rectangles. So if we draw a rectangle, oh no, that's fine. So that one of the rectangle's vertices are one of the points on the shape I'm trying to rotate, we can go and rotate the rectangle, because what I can do now, my center of rotation is the origin. And so if I now move this rectangle or rotate it 90 degrees, this rectangle is now going to lie flat. It's going to remain the same shape or the same size, but now it has been turned or rotated. And so this rectangle is still 5 units long and is still 1 unit wide. It has just rotated or turned 90 degrees clockwise. Now, what we also need to remember is where the point sits. So we can see that point A is on this top right corner of my rectangle, which means that when it rotates, it's going to remain in the same position on the rectangle. So my new point A is now going to sit at +5, -1. All right, now there's a lot going on here. So what I'm going to do is I'm going to write my new coordinate down on the side, 5, -1, just so that we're very clear of where we're drawing our points. Okay, so the rectangles is quite an easy way to work with rotations. Obviously, as you get more and more comfortable, you might not need to draw in the rectangles, but it is a very helpful tool for us to go and do rotations. Okay, so we'll do the same thing with point B and with point C. Now, point B, it's just a much smaller little square. So when I rotate it, it's actually just going to end up down below. Remember where B is in terms of on the shape or on the rectangle. So when I now rotate this, point B is going to sit down here. It's rotated or turned 90 degrees. So B dash, and remember we use that apostrophe to illustrate that a point has been transformed or changed in some way. This B dash is then at 1, -1. Apologies, my pen just decided to not work for a second. Okay, and then the last point we have is C. We draw in our rectangle, grab another color, seeing as we've started out like this. Whoops, draw our rectangle, obviously much neater. We're now going to rotate this rectangle. I'm clearly not ready to go back to teaching tomorrow. And we put this point C in the same position on the rectangle, and we can see that point C dash is now, golly, Miss Molly, is now going to be at 1, -2 once we've rotated. Now, guys, remember, it's all very well having your points here, but we do actually need to draw in the shape that we're working with. And so once we have got the 3 points that we want, we draw in, obviously with a ruler, our triangle, and we can see that this triangle, originally ABC, has been rotated or turned 90 degrees to create the new triangle A dash B dash C dash. Okay, my triangle is a bit dodgy looking, but hopefully we can see how we got to these 3 points. Alrighty, so take your screenshots if you need. I see your hand. Do you have a question?
Yes, ma'am.
Yes.
So, ma'am, I just want to say I don't get anything that you were saying, ma'am.
Okay, well, this is a recap from our last lesson. So I would encourage you to go and watch the last lesson's video on Watobe's website, and hopefully it'll make a little bit more sense. Okay, because we have done this already last week.
Yes.
Okay, but we are going to do another example, so hopefully that'll help.
Yes, ma'am.
Okay, guys, so like I say, take your screenshots. This is a revision, so we have done this, and if you are feeling a little bit unsure, as Yolanda is always telling us, it's okay to feel unsure, but remember that you can go and watch the videos to recap what it is that we've spoken about. Alrighty, so let us, oopsie daisies, let us have a look at a second example of rotations. So here we've got rotate the triangle ABC 180 degrees about the origin. Now this is a slightly different one because unlike in question A, where I told you to rotate it clockwise, I haven't given you a direction here. I just told you to rotate it. Now, if you remember, or if you were with us in Wednesday's lesson, I spoke about the fact that when we rotate 180 degrees, we don't need to have a direction, because whether you rotate it anti-clockwise or whether you rotate clockwise, you actually end up in the same position. And so we never need to have a direction for 180 degree rotations because you end up in the same point anyways. Okay, now here's a couple different ways that you can do this. Again, completely up to you. I would use the rectangles. So when we look at a point, let's start with point A, because I'm going to get you to do the last two by yourselves. We're going to draw in our rectangle, and we now want to rotate 180 degrees. Now I would do it in steps. There's no need to try and rush to get to the answer all in one go. I'm going to head in a clockwise direction, but as I've told you, if you go anti-clockwise, you will get to exactly the same point. So if I do my first rotation of 90 degrees, this rectangle turns and now ends up here with point A sitting, with the new point A sitting at 1, -2, but that's only a 90 degree turn. I still have to go another 90 degrees. So this rectangle now has to turn another 90 degrees and ends up in this position here. And so if we sort of total up the entire rotation, we've gone 180 degrees because we've done 2 90-degree rotations. I can see that my point A dash must end up at -2, -1. And so I've got my first coordinate for my triangle that's rotated 180 degrees. All right, so guys, what I'd like you to try is tell me where the new coordinates of B dash and C dash are going to be when you do the same rotation 180 degrees of those 2 points. Use your rectangles if you feel more comfortable with that, but essentially I want you to finish off this rotation for me and get those new coordinates. So have a go. If you're feeling comfortable, you're welcome to pop your hand up, or you can put your answers in the chat. That's absolutely fine. Remember how we label coordinates? It's with the apostrophe to show that it has been transformed.
can do this, my people. Yes, I see those answers coming in. Well done, guys.
Nice, guys. Okay, and like I say, remember how to label those points, super important. Okay, is anyone feeling like they'd like to maybe raise their hand and tell us what the coordinates of B dash and C dash are? Give everyone a second to decide if they'd like to. No one. Oh, golly. Okay.
So my babe, I believe in all of you. So you just have to be confident and remember that we are here also to help, okay? So you can raise your hand and give it a try. Okay, Mona
liking
Lisa.
the answers on the chat so far are really good. So I think you guys can back yourselves.
Yeah. Buntle, Tabiseng. See you, Tabiseng is like, I'm so ready with my face today.
Okay, guys, I get it. We're not there yet. That's okay. Like I say, everyone who's put something in on the chat is looking really good. So well done. And if you're not feeling so confident to put a hand up, that's absolutely fine. Don't you stress. Hopefully there'll be something that you're a little bit more eager to answer. So let's just quickly do our coordinates for B and C. So if I draw in my rectangle for B, there it is. I rotated the first 90 degrees. And point B will now sit at 3, -1, but obviously I need to do 180 degrees, so I rotated another 90 degrees, and my rectangle ends up here with point B dash at -1, -3. Okay, so some of those answers were coming through already on the chat, and that's awesome. The final one we need to do is then obviously point C. I need to just try and find a better color here. Point C, the rectangle is quite a big one. It's 4 units long and 3 units wide. It's good enough. So when we rotate it, we now have point C, the first 90 degrees sitting at 3, -4, but we still need to rotate it another 90 degrees. And so point C ends up sitting at -4, -3, which I saw coming through quite a bit on the chat. So well done, guys. Right, once we've done that, obviously all of these rectangles we would do in pencil so that we can erase them afterwards so that we're not sort of making a mess of our diagram. That would be point B. We can now draw in our triangle, obviously with a ruler and a pencil, and we have rotated this triangle 180 degrees. Now we can see that if you sort of imagine a pin in the middle here and a piece of string attached to one of the vertices of the triangle, if you now move that 180 degrees, so imagine like your protractor measuring the angles, we can see that that rotation has occurred according to the instructions given to us. Okay, so take your screenshots if you need. There was a question that I got sent, and I just sort of want to just mention it so that you guys are all aware. The question was, can we ever rotate something 360 degrees? Now, you definitely can, but what I want you to bear in mind is that a 360 degree rotation actually ends up in the same spot. So if you imagine a very basic Cartesian plane, and if I said rotate this point 360 degrees, 360 degrees is a full circle. So you actually end up at that point anyways. And so nothing would change in terms of the coordinates if you were to go a full circle. It is something to bear in mind. It's not really something that gets asked a whole lot, but just so that you know, if you ever are asked something to do with a rotation of 360 degrees, you know what it means and what your resultant image would be. Okay, so just bear it in mind, not really something that we ask, but just so that you have it. Alrighty, so I'm assuming we've all got our screenshots. So let's have a look at our new transformation for today, which is enlargements and reductions. Okay, so there's a broad sort of term for enlargements and reductions, which are called dilations. Okay, and dilations is basically a change in size. So whenever we see this word, or like I say, enlargements or reductions, we are talking about a change in size. So either we're making it bigger or we're making it smaller, as Kia has said on the chat there. So it is a change in size. Either we're going to make it bigger, so that would be an enlargement, or we're going to reduce it, i.e. make it smaller. Now, one of the important things that we need to know when doing dilations or enlargements and reductions is what we call a scale factor. And basically as a scale, basically a scale factor tells us how we change the size. So am I making it twice as big? Am I making it 4 times as big? Am I making it a half? Am I making it a quarter of the size? How much bigger or how much smaller am I making the shape? So let's maybe put that in there. And because clearly my writing today is a bit dodgy. How much bigger or smaller are we making the shape? That is what a scale factor is. Ooh. Everything's going everywhere. Okay, now there's a nice little trick that we can use when doing enlargements and reductions that has to do with knowing what our scale factor is in order to create our new shape. So let's have a look at our first example so that we can see how we would go about doing this. Now, again, much like rotations, we have a center of dilation or a center of enlargement or reduction, and we're going to work with that being the origin. It doesn't always have to be the origin, but at this point in grade 8, that is what we're going to work with, and I'll explain what that means in a second. So here we've been told to enlarge the triangle ABC by a scale factor of 2, where the origin is the center of enlargement or dilation. So before we even stress about that, let us write down the original coordinates of A, B, and C. So you can either put it in the chat or you can raise your hand. Can someone or can anyone give me what these original coordinates of triangle A, B, and C are? And remember, guys, coordinates X first and then Y. Okay, Bontle, which one do you want to give me?
Ma'am, I want to give 4A.
Perfect, tell me.
A is 1, 1.
Excellent, thank you. So guys, the coordinates of A, 1, 1. Tiamo, do you want to give me B?
Yes, ma'am.
Tell me.
B is 2, 3.
Excellent, thank you. Okay, so B is at a coordinate of 2, 3. Bridget, would you like to give us C?
Yes, ma'am. C is 4, 1.
Excellent. Well done, guys. So we have got all of our original coordinates for this triangle ABC. Okay, now the little trick that we use when we want to get our bigger shape or our smaller shape is we times all of the coordinates by the scale factor. So if I now want to get to the new coordinates, I need a little bit more space here, I'm going to multiply the X and the Y coordinates by the scale factor. Now we use a symbol of K for scale factor. Not super important, but just so that if you ever see K equals, K means scale factor. Okay, now this makes sense, right? If I want to double something or make something twice as big, I'm going to times it by 2. And so it makes sense that when I'm wanting to enlarge a shape, or if I'm wanting to make it smaller, and we'll get to those in a second, I'm going to multiply what I'm working with. Okay, so if we start with just the point A and we apply the scale factor, I want to make the coordinate of 1, 1 twice as big. Okay, so let's times it by 2. this new coordinate A dash would now be at 2, 2. So if I plot that point, it's in the middle of my triangle, but that's okay, it doesn't really matter. And I've got my larger coordinate. Now, right now as one single coordinate, we can't really see that very clearly. When we go and draw in our triangle, it will make a bit more sense. But this is how we know we've enlarged it. If we go to the center of enlargement, which remember is my origin, and I draw a line directly to the original coordinate, I can see that this is cutting directly through the middle of one square. Now, again, it would make sense that if I'm going to double it, that line for my new coordinate should cut through 2 squares because it must be twice as big. And if I now draw a line from my center of enlargement to the new point A, it cuts through 2 squares. So I've made it twice as big. And so this is how our center of enlargement or our center of dilation is quite important, so that we can see that we have actually increased my shape by whatever scale factor I'm working with. Okay, so I'm going to say it again. If we look at our original coordinate A and I draw a line from the center of dilation or the center of enlargement, which in this case is the origin, which is what we said in the original question, I can see that that line cuts through 1 block diagonally. If I now go to my enlarged coordinate A dash, I can see that it's cutting through 2 blocks. That makes sense. My scale factor is 2. It needs to be twice as big. Right, so how you choose to do enlargements is really up to you. I think the multiplication thing is quite easy. You could use this whole line concept to go and work out your coordinates. So if we have a look at the coordinates of B, if I times B's coordinates, both the X and the Y by 2, I would get 4, 6. And so that would be my new coordinate B dash that I would plot at 4, 6. If you wanted to use the lines, just that you can see, I don't really find the lines as useful as the multiplication, but just that you can see, if I draw a line from the center of rotation to B, I can see that it sort of cuts through a rectangle that's 2 by 3 blocks wide, which means that the rectangle that the line should cut from the center of dilation to B should now be 4 blocks wide, twice as big, and 6 blocks long, which it is. But this gets quite complicated, which is why I'm not a huge fan of the lines. Multiplying your coordinates is a whole lot easier. Okay, so we've got A and we've got B. Does someone maybe want to raise a hand, or you can pop it in the chat? Can someone give me the new coordinates for C dash when I multiply those coordinates by 2? Okay, Kayla, can you tell me?
Yes, ma'am.
Yes.
It's 8 and 2.
Excellent, well done. So guys, if I multiply that by 2, I get the coordinate 8 and 2, which is C dash. Now, obviously with a ruler, we're going to draw in our sides of our triangle. And I can now see that my blue triangle A dash B dash C dash is twice as big as my original orange triangle ABC. And that is just by timesing by the scale factor. Okay, those of you that are saying you're lost, if you can maybe try and explain to me exactly where you're lost, that would be quite helpful for me to try and help you. You can pop it in the chat or you can raise a hand. But essentially all we're doing is, because the instructions told me that to enlarge the original triangle by a scale factor of 2, I then multiplied each of my coordinates from the original triangle by 2, so by that scale factor, in order to get my new coordinates. I made them all twice as big. All right, Sibongo Kutle?
Ma'am, can you hear me?
Yes.
Ma'am, I wanted to know, why did we add lines? Okay, so when we moved up from the central point, we moved up, yes, to 6, but we had another square, ma'am. Why did we add a square?
So the lines are basically to show me that the distance from my center of dilation or my center of enlargement also needs to increase. So if I go back to my lines, that line from the center of enlargement to the original A is 1 block across. If I now enlarge it, do you agree it should be 2 blocks across to create my new point? If my scale
Yes, ma'am.
factor is 2. Okay, perfect. So now when I draw a line going 2 blocks across, I hit this new point, A dash. And that is essentially one other way that we can go and do enlargement. So if I go, let's take, for example, C. If I draw a line from the center of enlargement to the original C, do you agree with me? It's cutting through 4 blocks now.
Yes, ma'am.
Okay, so now if I'm going to, yeah.
But you don't have the blocks anymore. There were blocks. They were like squares that you had put on either sides of the lines. I understand this part.
So
Yes, I
this one, when
understand,
I said
but I
over
don't
here,
understand the block.
that. Those blocks there.
Yes.
Okay, so all I was trying to
Yes.
show you, there is that what we would do is we would take that rectangle that I've just drawn and I would have to double it in size in order to create, or in order to apply the scale factor. And so if I do that and I double it, I get to my new point B. Okay, so guys, these lines are basically just to show you that when I enlarge it by 2, I need to double in size what I'm working with. But the lines aren't like, they aren't important. Ignore the lines if they're confusing you. What we need to be able to do is we need to be able to multiply our coordinates, so these original ones, by the scale factor. So here, if we took, if we took these coordinates and we multiplied each of them by 2, so 1 times 2 and 1 times 2, we get 2 and 2. And so by doing that, I have enlarged my shape. Okay, so using the scale factor, we times our coordinates by that 2, which is our scale factor. Okay, now we are going to do some more examples, but I think let's maybe take a little brain break here before we, we head into our next example. Now, guys, remember your brain break is, you're welcome to give it a try. Otherwise, it is your opportunity to just get up and stretch and move your body a bit before we carry on with our enlargements. We are going to do more, and I'm going to leave off the lines now. So we're just going to do the multiplications because I think that'll be much easier for us to work with. Right, your brain break, remember, you're trying to work out the value of the scissors, the pin, and the pencil. Oops, sorry. So once you've got some answers, you're welcome to either raise your hand or you are welcome to pop it in the chat. Completely up to you. I'm glad you guys enjoy the joke. Okay, I can already see some hands. Nice. Bontle, do you want to tell us any values here?
Yes, ma'am. I think for number 1 is 7.
So the pairs of scissors is, oh golly, Miss Molly. Are you saying one scissors? Oh, I can't speak English there. One pair of scissors is 7, or both pairs of scissors together is 7?
I mean, 1 pair of scissors is 7.
Excellent. Well done. Okay, so guys, each of these pairs of scissors is 14, because 14 plus 14 plus 14 gives us 42. And so as Bontle has now told us, if we want to go and work out what the value of 1 pair of scissors is, that is then half of 14, which is 7. Okay, so every time I see a pair of scissors, I'm working with 14. Every time I see 1 pair of scissors, I'm working with 7. Okay, so we've got a little bit of the way here. I am going to go back to the question we were on, so don't stress if you need to take screenshots. Let's finish off our brain break and then I'll definitely go back. Okay, so we're on the second step. Bontle, your hand's still up, or you want to give us another one?
No, ma'am, sorry. I'll put it down.
You're welcome to try if you'd like. Okay. Nondiwe, do you want to tell us the value of anything else?
Hi, ma'am.
Hi.
The 2 pins is 16.
Excellent. So what is 1 pin?
It's 8.
Excellent. Okay, so guys, exactly. The double pins is 16. Now we needed to think carefully about this step. There's a couple different ways you can go and do it, but we knew that we were adding 14 and we were multiplying by 14. So if you just think about solving an equation, if we subtracted 14 from 138, we get 224. And then we have to ask ourselves 14 times what gives me 224, and it's 14 times 16. And so that gave us that the 2 pins were 16, but 1 pin by itself was 8. So now we need the value of the pencils. And Buntley, I see your hand again. Do you want to give us the pencils?
Sorry, ma'am, I'm still trying to figure it out.
Okay, no problem. Right, Mona Lisa, do you want to tell us what the pencils are?
Yes, ma'am.
Okay, tell me.
I said the pencils are 9.
Okay, so 9 times 9 is 81 plus 8 is 89. Excellent. So what are 2 pencils?
18.
Perfect. Okay, so now that we've got our 2 pencils together, we actually know the values of all of the sort of unknowns in my last equation. And so now hopefully I can go and hopefully I can go and find what my final answer is. So Bridget, do you want to tell us what our final answer would be?
Yes, ma'am. The final answer will be 134.
Perfect. So which operation do we need to do first?
8 plus 18 times 7.
Okay, so guys, remember when we are working with multiplication and addition, we always do the multiplication first. So 18 times 7 is 126. And then I will go and add the 8, which gives me that 134 that Bridget just told us. Okay, so it's very important that we do go and work with our order of operations or order of work, because the multiplication has to happen first before I do the addition of 8. But 134, absolutely. Lenka, do you have a question? Okay, guys. So remember, just a fun little brain break, not something you need to stress about at all. Just something to give your brain a break before we carry on. Okay, so the joke, for those of you that are a little bit confused, basically, if we were to put a belt around a 0, so imagine a belt around him and like squeezing him in, it would create 8. And so 0 is saying, nice belt to 8. Right, so Lundeka, exactly, we need to use BODMAS in order to get our answer for the last one. We have to do the multiplication first because that is the operation that I need to start with. Alrighty, guys, so I'm going to go back to that question that we started with, just in case some of you wanted to take a screenshot. We are going to have a look at quite a few more, so don't you stress. We're going to do a couple more examples and hopefully it'll make more sense as we go along. So there it is. If you need to take a screenshot, I'll give you a second or two and then we'll move on to another one.
You guys are doing really good, my pebs. I'm so proud of you. Remember, we are doing more examples. So you understand, okay, for those who didn't get it the first part. So this is the second part. Make sure you understand, okay? Let's do this, my pips.
Okay, so guys, let's have a look at our next question over here. So I'm gonna make this a smidge bigger just that we've got it there. Okay. Excuse me. So reduce rectangle ABC, and as I'm saying this, maybe let's do another enlargement before we just get excited. Okay. I'm just chopping and changing my order here. Let's do an enlargement before we do a reduction so that we're all happy and on the same page. So let's have a look at this one here. Enlarge the following quadrilateral ABCD by a scale factor of 3, where the origin is the center of enlargement or dilation. Lots of information here. Basically, what this is saying is make the square 3 times bigger. That's it. So we know that we have to have the scale factor, and they've told us the scale factor is 3. And as long as I know how much bigger or smaller I'm making my shape, I would just multiply my original coordinates by that scale factor. So let's quickly do this. You can raise your hands, you can put it in the chat. Can someone give me the original coordinates of point A? So from this like pinky red, it's not a rectangle, square. Bontle, what are the original coordinates of A?
Ma'am, it's 2, -1.
Perfect. So A is at 2, -1. Bridget, tell me the original coordinates of B.
Ma'am, it's 2, -3.
Perfect. 2, -3. I also just picked on you. Did you have a question or did you want to answer?
I just wanted to answer.
Good. Well done. Oh, golly. Sorry, guys. Fazika, tell me C's original coordinates.
Hi, ma'am.
Hi.
It's 4, -3.
4, -3. Perfect. Now, do you want to give us D's original coordinates?
D is 4, -1.
Excellent. Okay. I know there were other hands. Don't stress, guys. We're going to do lots more, so there'll be opportunities for you to answer. Those are our original coordinates. So remember, as long as we know what the scale factor is, I'm now going to take the scale factor and times all of these coordinates by the scale factor, which is 3. So that's all I need to do in order to triple the size of this shape. So let's start with the coordinates of the new A, which would be A dash. So, okay, Bontle's hand's already up. Bontle, are you wanting to tell me what the new A dash coordinates would be?
Yes, ma'am. It would
Tell
be
me.
6. It would be 6 -3.
Excellent. So guys, we would times the 2 by 3 of the original A coordinate, and we would times the -1 by 3 of the original A coordinate, and we would get 6, -3. So that takes me to a coordinate of A dash over there. Alrighty. Oh, lots of hands. All right, Tile, tell me the new coordinates of B dash.
Ma'am, the new coordinates for B dash is 6 to 9, -9.
Good. So the new coordinates for B, I find by multiplying the original coordinates by my scale factor, so multiplying them by 3, giving me 6, -9. So this would be B dash down at the bottom here. All right. Oh, golly, sorry, I'm trying to find people. Elenka, can you give me C dash?
Hi, ma'am.
Hi.
C is 12, -9.
Excellent. So 12, -9, because we times the original ones by 3. And so I get C dash down at the bottom here. And oh gosh, hands are changing. Anake, tell me D dash.
Hi, ma'am.
Hi.
D is equals to 12, -3.
Excellent. So D dash is 12, -3. And now that we've got all 4 of our coordinates, I can obviously with a ruler draw in my enlarged square or my enlarged quadrilateral. So guys, all we actually need to do is times by the scale factor, and that will give me my larger shape. Now we can see it's definitely larger. The original square, the side lengths were all, oh golly, the side lengths were all 2 units long. We're going to get there in the end. So this is 2 units. If I want to triple that, the side length should now be 6 units long. If we count how many blocks this is, it is 6 units. So it has tripled in size. And so by using my scale factor, I've been able to make it bigger. Orotile, do you still have a question for us?
Ma'am, I just wanted to ask, should we draw the bigger square once we're done doing the calculations?
Yes, definitely. So once you know where all of the new coordinates are, you can draw in your larger shape.
Thank you, ma'am.
Pleasure. Okay, guys. So let us go back to this one over here. So we've got another quadrilateral, A, B, C, D. In this case, it's actually a rectangle. And we have been told to reduce the rectangle now by a scale factor of 3. Again, where the origin is the center of enlargement, but that will always be the case. So we don't need to stress too much about that. We just need to figure out what this is saying. All right, now guys, I've told you, or we've sort of been looking at how to enlarge shapes, so how to make them bigger. This is now telling me to reduce. So if we are reducing something, we're making it smaller. So that gives me a clue that the shape I'm going to eventually draw must be smaller than this blue one that I've been given. The next thing is I need to know how much smaller am I making it, okay? So it tells me by a scale factor of 3. So essentially, I need to make this shape 3 times smaller than what it originally was. And already I can see on the chat some awesome sort of inferences being made here. We are now going to have to divide. If we want to make something smaller, I will divide. And so when I'm doing reductions, I'm now going to divide all of my original coordinates by the scale factor. Okay, I'm going to write that in a second, but let's write down our, let us write down our original coordinates for A, B, C, and D. So from this blue rectangle, what are my original coordinates? Bontle's on it tonight. Bontle, do you want to tell me A?
Yes, ma'am. A is 3, 3.
Perfect. So A is at a coordinate 3, 3. Excellent. Thank you. Okay, sorry guys. Things went weird there. And I know you've told me how to pronounce your name, and you can correct me if I get it wrong. Matlongonolo? B?
I think you got it right. Mahlonolo, can you unmute on your side? There's a little box that comes on your device. You just have to click on it and then you can talk to us because we cannot. There we go.
Can you hear me now?
Yes.
Now we can hear you.
Yes, ma'am. So B is 3 and 6.
Excellent. So B, the original coordinates are 3, 6. Well done. Thank you. Got there in the end. All right, Lorraine, do you want to tell me C? Lorraine?
Madam, can you hear me?
I can hear you now.
Okay, C is 9 and 6.
Excellent. Well done. Thank you. So C is 9, 6. And then we still need to get D. Oh gosh, I've got so many hands. This is awesome. Bonganele, tell me D.
Ma'am, D is 9, 3, ma'am.
Excellent. Okay, I know there were lots of other hands, guys. Don't stress. I'm going to ask for some more coordinates when we do the reduction. So keep your hands ready and hopefully I can get some answers in a second. Okay, so we now know the originals. I am reducing, so I now need to be careful. I need to make it smaller, which means that when I go to my new coordinates, I'm going to divide now by the scale factor because I am reducing. And in this case, my scale factor, we were told, is 3. So I'm going to divide all of these coordinates, both x and y, by 3. So let's start with the first one. Guys, someone isn't on mute. Not a problem. Just remember to mute yourself after you've answered a question. Okay, just that we're not getting too much noise. Okay,
That's Lorraine, so I'm gonna mute Lorraine. There we go.
Thank you. So if we have a look at A, let's just start with the original one and do it together. I need English. I now want to divide both of these original coordinates by the scale factor. So I want to divide both the x and y by 3. Now we know that 3 divided by 3 is 1. And so my new coordinates for A dash are going to be 1, 1. So I've got A dash. I now want B dash, C dash, and D dash. Okay. Someone has got a number as a username, so 539403334. You can tell us who you are and you can tell me what B dash is.
Hi, ma'am.
Hi.
Ma'am, my name is Zikuye.
Zikuye, I think we actually have already spoken about this. Okay, cool.
Yes,
so,
ma'am.
Okay, Zikuye, tell me B dash.
Ma'am, B dash is 1 and 3.
What's 6 divided by 3?
Sorry, ma'am, it's 1 and 2.
Excellent, well done. Okay, guys, so again, we divide the original coordinates by 3. We know 3 divided by 3 is 1, and we know 6 divided by 3 is 2. So we've got B dash. All right. Sibongo Kutlet, tell me where are we at? C dash. Yes, C dash.
C dash is 3 and 2.
Excellent. So again, we divide the original by 3, and I get my new coordinate at 3, 2. Awesome. Well done. Excuse me. Kia, tell me what D is.
Ma'am, D is 12 to 1.
Why 12?
No, 27. Sorry.
Okay, so remember what we want to do is we want to divide this 9 by 3. So what's 9 divided by 3?
27. Right?
We're not timesing, we're dividing.
Oh, it's 3.
Excellent.
Well done, Kia.
3, 1, as you said. Awesome, well done.
Thank you, ma'am.
D dash is 3, 1. Now that we've got all 4 of our coordinates, we can draw in our rectangle. Obviously, you'll do it with a ruler. But now we can see that this red rectangle is 3 times smaller than my original blue triangle. All right, so guys, when we are doing reductions or enlargements, basically what we're needing to do is we're needing to know what the scale factor is so that we can either multiply or divide by it. All righty, so take your screenshot if you need.